Okay, so now we have another example here. These last two examples that we're going to look at are a little bit trickier. But I want to see if you can pause the video and do the isolation step on your own. I'm sorry, the separation step on your own. Okay, so when we separate this, if we bring y over to the left-hand side, dy over y should equal, when we go over to the right-hand side, we're going to have multiply both sides by dx, and we're going to divide both sides by x squared. And so that is the separated equation, right? Now we're ready to integrate both of those sides. So when we go to do that, see if you can integrate, actually. Pause the video for a moment and see if you can do the integration step. Okay, so I'll work that out. ln of absolute value of y is going to equal, now be careful, it's not ln of x squared. That's a no-no. This is now a power rule. Remember, the integral of dx, I'll write this on the side, over x squared is the same as the integral of x to the negative 2 dx. So don't fall for, we get a little bit lulled into thinking that everything in the denominator has to give us an ln. This does not, okay? So the antiderivative of that is negative x to the negative 1, which is negative 1 over x plus c, right? Let's call that a c1. All right, I think you're used to isolating y in this case. So we'll go right ahead, exponentiate both sides. Absolute value of y is equal to e to the negative 1 over x plus c1. This point, we can go right to saying that that absolute value of y should equal a c times e to the negative 1 over x. And you may make that jump in your homework, where you go, if I see the line right here, and then you go directly to this line, I'm okay with that. So people know what you did at that point if they understand this subject. So now, once again, this constant can eat the absolute value signs because the constant can be plus or minus. So we can just rewrite this as c times e to the negative 1 over x. So that is your general solution. We could find initial value solutions. If we give you a point or sets of points that it goes through, we could find different initial value solutions, but that is the general solution, right? Last example is dy dx is equal to xy minus x. A little bit better there. Okay, so this looks a little bit like the problem that we said we couldn't do because there's a function minus a function. Remember, we said if we're going to be able to do a problem, we need to be able to get it into one of these forms. Dy dx equals f of x times g of y, or a quotient of those two factors, right? So it may look like we're at the end of the road, but we're not. We can factor. So what is common to both terms on the right-hand side? An x. So we can do some algebra. Here's the algebrate ahead of time. X times y minus 1, right? So now that we have that, we can separate, right? See if you can pause the video and see if you can separate, integrate, and isolate the answer. Okay, I'll work through it and I'll do each of those steps, and you could pause if you didn't get all the way to the end after I show you each of these steps. So the separation step would be this. Okay, so I finished separating. So now I'm ready to integrate both sides. So if you got stuck there, see if you can now integrate this. All right, so this is technically a u substitution where u equals y minus 1. So du dy is 1. So du equals dy. So when I do all of that, the integral on the left-hand side becomes the integral of du over u. And so the answer would be ln of absolute value of u, which would be y minus 1. So back to the problem, we can say this is ln of absolute value of y minus 1. All right. And you could just sort of make a quick educated guess that that would be the answer, and then just double check by doing a chain rule on that, and you see that it would get you back to where you started from. The right-hand side, when you integrate, is x squared over 2 or 1/2 x squared, either one, plus c1. All right. Now, if you didn't get that far, stop and see if you can finish this problem by exponentiating. Okay, but we'll have absolute value of y minus 1 is equal to e raised to the x squared over 2 plus c1. And like I said in the last problem, you can now say that c times e to the x squared over 2. All right, the constant can be plus or minus. So get rid of the keyboard there. Oh, that's going to be pain. So I'm going to have to write down here y minus 1 is equal to c times e to the x squared over 2. Just ignore that little r over there. And therefore, y is equal to c times e to the x squared over 2 plus 1. That is your general solution. All right, so notice the little extra step. We had to do a little factoring at the beginning to put this in a form that we can separate. So most of these problems are designed to work. So if in its original form it doesn't look like it will work, look for some algebra. Often factoring will do the job, that will put it in a form where you can separate and complete the problem.